This project was conducted by Justin Jones and Samuel York. The advisor for this project was Professor Bradley Johnson, and the sponsor of this project was the Madison Group. And this is our capillary and on-machine slit diameter comparative rheology project. So the goal of this project was to compare viscosity models created by a capillary rheometer and an on-machine slit diameter and compare those to the actual molding trials for 30% glass-filled polypropylene. So the capillary rheometer is important because it can produce shear rates at a wide range of 1 reciprocal second to 10,000 reciprocal seconds, and these shear rates correlate well to the actual injection molding process. However, on-machine slit diameters put the material through this same shear and thermal history as the injection molding process, and this is especially important for glass-filled polypropylene because the screw is able to break down the glass fibers, which actually goes on during the injection molding process. So the first step in this project was designing a slit diameter to characterize the material. Once that was done, the material was characterized in the capillary rheometer and the slit diameter, and a mold flow material file was created for both methods. So using this material file, we were able to generate simulations for both the capillary rheometer and the slit diameter. And once those simulations were run, actual molding trials were ran, and a comparison between the simulations and the actual molding trials was made. Figure 1 shows the slit die A half insert, and Figure 2 shows the slit die B half insert.
So originally we had predicted that the on-machine slit die based model would predict pressure drops within plus or minus 10% of what was actually found when molding. This was disproven as the actual predicted pressure drops were overestimated by 30% by the slit die simulation. And originally we had predicted that the capillary rheometer model would predict pressure drops within plus or minus 20%, whereas the actual simulations had overpredicted by 73%. Another important conclusion that we found was that the on-machine slit die rheometer and the capillary rheometer both had very similar viscosity models, which was important for validating our methods. And we also found that the pressure predictions at the low velocities of each temperature were accurate within 10% of the actual molding trials for the slit die model. We would like to thank Professor Bradley Johnson for advising the project, the Madison Group for sponsoring our project, Eric Foltz for guidance and being our sponsor contact, Steve Brenna for supplying material and his guidance, Professor Jason Williams for slit die design help, Andy and Chris Bartlett for tooling help, Adam Gummerson for processing help, and Josh Lutz for capillary rheometer training and processing help.